In this video, we're going to review how to solve a system of equations algebraically. What we're really looking for is the values of x and y that make both equations hold true. Okay, so first thing we want to do is when we look at our equations, we need to get either x or y by itself in one of the equations. If you look at the second equation, this x right here is actually going to be the easiest thing to get by itself. The y has a 2 in front of it, so you may wind up with fractions if you try to get y by itself. So x is actually, even though it takes 2 steps to get it by itself, it's actually going to be the faster thing to do. All right, so let's start with that equation. And first thing we can do is add x to both sides of the equation. And what's going to happen is the x's cancel on the left-hand side of the equation, leaving us with 2y. And then on the right-hand side of the equation, we're left with x plus 2. Now we still have to get the x by itself, so we could subtract 2 from both sides of the equation, leaving you with 2y minus 2 equals x. Or if you want to put the x in front, we could have x equals 2y minus 2. Now, since x is all by itself, we can take what x is equal to, this 2y minus 2, and we can replace it for the x in this first equation here. So, instead of having x squared plus 4y squared equals 4, we can replace that x with what it's equivalent to, the 2y minus 2. Okay, so again, we took this 2y minus 2 and replaced it for x into the other equation. Now what we did was here we created an equation that contains one variable. There's only y's in it. And once you have one variable, you can solve. So the first thing we're going to do is we're going to rewrite the 2y minus 2 squared as 2y minus 2 times 2y minus 2. And we're just going to double distribute, so we'll distribute the 2y to both terms and then the negative 2 to both terms, leaving us with 4y squared minus 4y minus 4y plus 4. And then you can just bring down the 4y squared and the equals 4. Okay, from this point we're going to combine our like terms. So we can combine the 4y squared with this 4y squared to give us 8y squared. We can combine the negative 4y and the negative 4y to give us negative 8y squared. And you can bring down the positive 4 and the equals 4. Okay, now we're going to subtract 4 from both sides of the equation because we want to get the right-hand side of the equation equal to 0. That way we can factor and solve. So you can factor an 8y out of both terms on the left, leaving you with y minus 1 in parentheses. Now from this point, if we made a t-chart in between the 8y and the y minus 1, on the left-hand side you would wind up with 8y equals 0, and you divide by 8, leaving you with y equals 0. And underneath the y minus 1, if we set that equal to 0, you'd wind up with y equals 1. Now keep in mind, these are only the y coordinates of our solutions. Okay, so if we wanted to find all points of intersection, what we found so far was we found that one of the y coordinates is 0, and the other y coordinate is 1. So we still need to find the x coordinates that go along with these. So what you can do is you can go back to, you can really use this first equation, the second equation, or what I like to use better is this equation that we created where x is already by itself. If we reuse this equation and substitute in our y values that we just found, we can use those to find x. So let's first start with y equals 0 over here. If we replace the 0 with the y in this equation, we'll be left with x equals 2 times 0 minus 2. If we replace it with the 1, we're left with x equals 2 times 1 minus 2. So when y is 0, 2 times 0 minus 2 is negative 2. And when y is 1, 2 times 1 minus 2 is 0. So what we can do now is we can go back up top, and we can say that when y is equal to 0, the x value that corresponds with it is negative 2. And when y is equal to 1, the x value that corresponds with it is 0. So these are our 2 points of intersection. And if you want to go back and check, you can always take those points. So let's start with a the coordinate negative 2, 0, and you can replace this negative 2 in for x, and you can replace this 0 in for y. So here you'd have negative 2 squared, which is 4, plus 4 times 0 squared, which is 0, so you'd have 4 plus 0 equals 4, which checks. If we replace those same two values in the second equation, it also checks. When you're done checking the first point of intersection, you could now take the second point of intersection and replace that into both equations to make sure it checks as well.